Problem number 6, the last problem of this practice exam. It's been a long trip together, wading through this, but we shall linger on. So, first, when you have a circuit like this, this is what we call series connections. And here's what it would look like if we were building it using those Castle kits that I purchased earlier this year. So you would have the battery case, which would look like this. Right? You'd have a battery here, and a battery here. Right? You'd have this negative part here and this kind of positive part here. And then the wires would come out like this. And the way we'd have these connected up, it would actually look so we'd have one light bulb here, and one here. And then we'd have our light bulbs connected like in series like this. So 1, 2, and 3, all connected up. And when we have this set up, of course, each light bulb individually glows a little bit dimmer than it would if it was just one light bulb. And this is what we mean by a series connection. Now, when you have light bulbs connected in series, the total resistance is given by adding them up. So we have 5 plus 3 plus 2 ohms, which is 10 ohms total of resistance. So if we want to get the total current, we're going to use the formula V equals I times R total. V total is 20. That's given here. And R total is 10. So our current ends up being 2 amps worth of current. Now what we can do is we can actually look at, I'll call this R1, I'll call this R2, and this R3, and we can look at the voltage across each resistor. So V1 equals I1 times R1. And the thing about current is, think of it as cars or traffic. This current never changes through a loop. So this I total goes through the whole circuit all the time. Okay. It's just the traffic, the amount of charge per second going through the circuit. So we have V1 equals this 2 amps that we calculated before times R1, which is 5. So we've got 10 volts going across this resistor. When we look at the second resistor, we have V2 equals I2 times R2. That's going to be 2 amps times the 3 ohms, which is going to give us 6 volts worth. And then finally for R3, we're going to have I times R3, which is going to be 2 amps, times R3, which is 2. And so we're going to end up getting 4 volts worth of voltage right there. Now here's the interesting part. When I add up all these volts, 10 plus 6 plus 4, I get a total of 20 volts consumed across the circuit, which is actually the energy put out by the battery. The energy per unit charge put out by the battery. So that is, we wanted to get the 2 amps of current, which is what we're asked for. And we were also asked for the voltage across each resistor, which are these numbers here. So that, in a nutshell, is your second practice exam. So now you have an idea of what your real exam is going to look like based on the 2 practice exams. You can kind of see what I changed, what I kept the same. And so I hope this is helpful. And I will see you either on Thursday or Friday for the exam.